this video I'll talk about the numerical that we already discussed in the degenerate and the non-degenerate case. Okay, so in exam we can ask, okay, this non-degenerate gas pressure. Okay, so let me just the chemical formula. I want to calculate the mean molecular weight in terms of atomic mass. So let me just the ratio वाला. Okay, so यो ratio को वाला हेर्नु है त. So मलाई के को सोधेको छ, find the ratio of non-degenerate and the degenerate pressure exerted by the non-relativistic case. So this is very important. This is the non-relativistic electron gas. Okay, in the start the temperature is given, density is given, chemical composition दिएको छ, that is 70% hydrogen and the 25% helium. So in such case, okay, in such case I can do what I can do. यस्तो केसमा चाहिँ I will simply use the formula. Okay, so what are the formula that I can use? Let me use this. Yeah. Okay, okay. Okay, so in non-degenerate case, okay, so before we start to solve some numerical, so this is a non-degenerate case. Non-degenerate case में के हुन्छ, the pressure is given by, we just derive what we derive, rho kt divided by that is mu है. यो कहाँबाट आयो कसरी आयो, in case if you are confused then तपाईले यो भन्दा अगाडिको भिडियो हेर्नु, we have derived everything. Okay, so that we are using directly here. अब यो mu भनेको के हो, that is a mean molecular weight. In case of non-degenerate case we can write it as alpha x plus beta y plus gamma z, and after substituting the value it is given as 8x plus 3y plus 2z. Okay, so this is the pressure, this is the mean molecular weight. In case of degenerate case, degenerate and relativistic case, so what is the pressure? Okay, non-relativistic case. Okay, so let me just start the non-relativistic case. So what was the pressure that we just derive in case of non-relativistic case? That is, it is given by, in case if you lost, okay, कताबाट आयो के आयो भनेर, please watch my previous video. Okay, so you will know that. So it is always given by, it is 1 by 20, that is 3 by pi, and then it is given by 2 by 3, that is h square by m e, and then it is n by b, and then 5 by 3. Okay, so this is the formula that I am going to use. And in case of relativistic case, my pressure is given as 1 by 8, 3 by pi, 1 by 3 h c, and again it turns to be n by b, that is 4 by 3. Okay, so n by b को ठाउँमा के लेख्न मिल्छ, density is given by mass by volume. I can rewrite it as what I can do is I can rewrite n mu, because it will cancel out, because mu is 1 by n, and this will be mh, and this will be b, and this n by b is equal to the density over u यता जान्छ mu mh. Question मलाई के दिएको छ, I need to find the ratio between the non-degenerate and the degenerate pressure. Okay, which is given by the non-relativistic. Okay, non-relativistic भनेपछि I need to use this formula for degenerate case, and for non-degenerate case I need to use this formula. Okay, so I have given that टेम्परेचर कति दिएको छ it is given as 2 into 10 to the power 7 Kelvin density दिएको छ 10 to the power 6 kg per meter cube है so chemical composition कति छ that is 70% of hydrogen र यसमा important कुरा अर्को in case of degenerate case you will use the mean molecular weight is divided by 1 2 by x plus 1 okay so this is how you can use now hydrogen कति दिएको छ it is given as 70% and the helium is given as 25%. Okay so before I calculate before I calculate T दिएको छ density दिएको छ okay we know the mh को value हामीलाई थाहा छ okay so that is the atomic mass unit of the hydrogen मलाई mu निकाल्नु पर्यो okay in case of the non degenerate pressure this is the formula so x को value कति हुन्छ since it is 70% of hydrogen that is 0.7 okay and then y को value कति हुन्छ 0.25 okay now z को value कति हुन्छ the remaining percent that is 1 minus 0.7 plus 0.25 हैन यो भने कति हुन्छ that is 0.70 80 90 that is 0.5 okay this value ल्याएर यहाँ यता सब्स्टिट्युट गर्नु x y र z को ठाउँमा that then you will get the mu को value पाइसकेपछि then you can calculate this equation okay similarly in this equation we only need the x को value सब्स्टिट्युट गरिसकेपछि यो भ्यालु आउँछ now everything is given okay यो 3 by pi h square थाहा छ me थाहा छ okay यो सबै सब्स्टिट्युट गर्नु भयो भने then you can easily calculate the pressure that is exerted by the degenerate case in case of non-relativistic case okay and then you just need to take the ratio of both two then you will get the required answer okay so this is how you can do र अर्को नेक्स्ट एउटा न्यूमेरिकल हेरौं another second type of question हामीले के सोध्न सक्छ भनेपछि the chemical composition sunko it is as follows 70% hydrogen and then 27% is helium but out of 70% only 40% is ionized and out of 27% only 80% is ionized यसले भन्न खोजेको चाहिँ as a 70% चाहिँ hydrogen को लागि as a whole 100% भयो त्यसबाट चाहिँ only 40% is ionized र similarly helium को लागि 27 भनेको it is an equivalent to 100% for helium and यसको चाहिँ only 80% is ionized okay so we know that we clearly know the mean molecular weight formula भनेको it is given as 1 by alpha x plus beta y plus gamma z so this is the ionization value alpha beta and gamma and x y and z is are the fraction of the part the gas have okay so in case 70% हाइड्रोजन छ भनेको that is the x को value okay 70% छ भने टोटल फ्र्याक्सन मा चाहिँ as a whole 100 total 100% मा चाहिँ 70% के छ हाइड्रोजन छ that is 0.7 now helium कति छ helium भनेको y हुने भयो y कति छ that is 27% that is 0.27 अब बचेको कति त that is x plus y plus z must be equal to 1 then z is equal to 1 minus यो दुईटाको सम ओके सो that will be equivalent to यहाँ मैले गरेको छु that is 0.03 now अब के भयो now that out of 70% the 40% is ionized okay so I will consider this 70% as the 100% of hydrogen and then the remaining 60% is not ionized simply okay hydrogen को 70% which is equivalent to 100% for hydrogen okay त्यसमा 40% चाहिँ ionized छ okay बाकी 60% चाहिँ के छ ionized छैन 40% ionized छ भनेको यसमा मैले के लाउन मिल्छ I can use the relativistic case so non relativistic को लागि के हुन्थ्यो alpha को value this is the number of particle emitted divided by molecular weight and similarly beta को value कति हुन्छ 3 by 4 र gamma को value it is always 1 by 2 because the heavier gas is always ionized so यो चाहिँ non ionized case को मा भयो अब ionized को केसमा it is always equivalent to 1 by 1 beta will be equivalent to 2 and since the heavier gas are always ionized so it is same 1 by 2 1 by 2 so this is 60% for hydrogen है अनि यो चाहिँ के छ 40% out of कति 70% of star सो एकचोटि यो लाउनु पर्यो हैन, के कुन केसमा 60% केसमा विच इज कम्प्लिटली आयोनाइज आई थिङ्क 60 न 40% इज आयोनाइज, ठ्याक्क उल्टो भएछ, दिस इज टोटली आयोनाइज भनेको त 40% हो नि हैन, 40% ए सिमिलरली द्याट इज 60%, ओके 60% अफ 0.7 के हुन्छ, द्याट इज कम्प्लिटली आयोनाइज, सो इट इज लेट मी से x1, यसको लागि अल्फा 1 कति हुने भयो, since it is ionized I can use this case, no 60% is unionized, okay it is unionized, unionized का अल्फा को भ्यालु कति हुन्छ 2 हुन्छ, सिमिलरली x2, अब बाँकी बचेको 40% के को 0.7 it remains ionized, ionized को लागि अल्फा को 2 अल्फा को भ्यालु कति हुन्छ, that is 1, ओके सिमिलरली हिलियमको केसमा के भनेको छ 80% is ionized, that is out of 27% 80% is ionized, that is 80% of 27, okay that is 80% of 27 it is ionized, the बाँकी जुन 20% बच्यो it is unionized, so this is unionized, so beta 1 will be from the ionized case, okay beta 1 will be ionized case 3/4 र next okay so कति पर्सेन्ट ionized भने अहिले 80% ionized, so for 80% we will use beta is equal to 2 and बाँकी remaining 20% को लागि we use beta is equal to this 3/4, okay so this is what it is given. Now gamma is always ionized, the Hebrew gas are always ionized, so both in ionized and unionized case we will have the same formula, okay now the mu को value चाहिँ कति हुन्छ, it is given as mu को value say we can use that 1 by alpha x plus beta y plus gamma z. Now I can use this since I have the two case here, okay so one case is on ionized case and on one case is it is not ionized, so I can use this alpha 1 x1 plus alpha 2 x2 and then beta 1 y1 plus beta 2 x2 and it is given as gamma z, and मैले के गर्छु माथिबाट ल्याएको भ्यालुहरु सबै यहाँ राख्दिन्छु, then I will get the mean molecular weight. So this is the idea here guys, so I hope you get the numericals, okay so this is overall यही क्वेशनहरु नै सोध्ने हो एक्जाममा, so I hope you guys get the concept, okay so किन आए comment section मा लेख्नु होला, okay I'll be more than happy to assist you guys, okay so thank you for your time and goodbye.